Greetings. It's been a while. So I've been pretty busy with my part-time work, so I have not had any time to work on my projects whatsoever. But yeah, now I'm trying to squeeze in some time, you know, get a little bit of work done on my game. Let's see. So I have this little issue that has been nagging at me for a while. It has to do with the world selection screen. So if you just give me a moment. So I have this particular issue, right? I have this box here, which is the highlighter. It's supposed to it's kind of a representation of which button is supposed to be in focus. So the button in focus, for the button in focus, the stats, the additional stats will be shown, right? The problem is that the label doesn't actually match where the highlighter is. So I want the opacity to be highest when I want the opacity of the label to be highest, right, if it is within the highlighter itself, right? So the problem is that maybe I can illustrate it. It's a little bit hard to put into words. It's my current implementation. Current implementation is such that the position of the label, right, like the 1, 2, or 3, the number here, the position of the label is determined by a sine curve, with the peak of the curve right smack in the center of the screen, rather in terms of its height, right, it's right smack in the center of the screen. So I don't want that. I kind of want it such that desired implementation. I want my curve to be where the peak of the curve, right, to be where the highlighter is, because this curve, right, determines the position of the label away from the button. So ideally, the label, right, should be closest to the button when it is inside the highlighter, but in this case you can't really tell, right? So you can see that this number here, 2, is kind of fighting for attention, right, with the 1. So that's not very good, right? Ideally we want something like this. This is really faded out, you see that? This 2 number is really faded out. This thing is extremely visible. And the position here, right, it's the closest to the button, right, compared to the other 2. So yeah, a few things to work on. So the desired implementation is, if this is my highlighter, and what's gonna happen is that the peak of the curve will be here. Something like that. So I want the curve shape to be dynamic. So during the dev chat, right, I was talking to Chow, right, he mentioned the use of curves, right, Bezier curves. And I thought, yeah, perhaps that would solve this very specific problem that I have, right, since I can control the shape of the curve. It has been a while since I've done curves though, so I'm going to try and use this session as a revision. Right, so I'm gonna try doing it. So I think the first thing I'm going to do is I'm going to create an empty room and then do my test there. Or maybe I can just do it here. Level 0, 0. Yep, level 0, 0 should be fine. I just need to know what this is. vector. Okay. Oh, it's a test object. Cool, I'm gonna use that then. Let me see what this test object has at the moment. And also check if I have like committed my work. Let me just commit my work first, just in case. Okay. Okay, got it. It's just this. Not a problem. Let me just remove this. I'm gonna remove all of this. Quadratic curve, quad curve, I guess. So I'm gonna start with I think I'm just gonna use a curve with 3 control points. Alright, 1, 2, 3. So the curve should look something like this. Right, with this 3 control point, the curve should look something like this. Alright, then of course there is the shell, right? The shell of the curve. There's a shell. It's the first layer of the shell, and then there's the second layer. Second layer will be, I mean, something like this, right? If the point is here, right smack in the center. Right, this will be the shell for the peak of the curve. Something like that, I guess. Not drawn very well, but you get the idea. Okay. Yeah, I'm just gonna try it out. Hopefully it slowly come back to me. If not, I'll just, you know, go online and search it up. Okay, T. T for the interpolation, right? So normalized range 0 to 1. What other parameters will I need for the curve? The 3 control points, point A, B, and C, right? So I will just quite start. And start and end and meet, I suppose, or handle, right? I think some people call it handle. this could be fun. Like maybe in future I can make some kind of a track editor, right? With cubic curves. Oh, I can't call it end. Can I just call it ABC? I think I'll just call it ABC here. There's a loop, that's cool. Let me look this up, eh? Given a percentage, got it. Cool. Value. Okay, so A to C. Hang on, those are... Ah, damn it. Look, points. Okay, hang on.
Invincible.
Hang on, I should change the naming convention. Quad curve. I'm just going to make the assumption that the array is properly defined. I'm not going to do any checks in there. So this is for the X component. Right? So Y component. bullet point. Okay, A to C, T. Hopefully it's not too hard to read. A to C, C to B. A to C, C to B, right? Let me see. I'm doing A and B and C. So A to C, C to B. There we go. This would be the implementation of a quadratic basic curve, if that's the right term. I'm just gonna test something first, alright? I need to test the t value. So let me just let me try out some stuff. Quad curve. Oops. No, let me think, eh? No, it's points.
The wood, an artificial paradise.
Not sure if it's safe to do this actually. A, C,
Paradise.
A, B, and C. Start point being the top, end point being the bottom.
Paradise.
Let's have a third point. The control point. Excuse me. Let this be in the center. Of course, this will only give us the points, so I have to draw it as well. Not sure if this will work. Let me test it out. This doesn't look like it's working. Hang on, let me draw this in. Is it the resolution? 100 points. Oops. Oh, it doesn't seem quite right, does it? Oh, right, I get it. I cannot use room height. Right, the room is actually pretty wide. Let me draw all the control points as well, just in case. Okay, looks about right. Looks about right. So what I need to do to test if the curve is working is to change the middle control point, right, the handle. Hopefully the mouse X and mouse Y is the space, right, the resolution is matches the GUI space. So I'm not sure if I resize the GUI layer. Oh, seems fine. Can I actually use this? Let me think. Because it doesn't really determine the peak, right? Like this curve doesn't... How do I put it? Hey Joffer, what am I doing? I'm trying to solve a problem with... I'm trying to solve a problem with the word selection. So if you notice, this particular button here, labeled 1, this should be the highlighted button, right? But the number 2 has a higher opacity. That's because the peak of my curve is like in the middle of the screen. So I'm trying to fix this problem. Like Chow mentioned, looking into Bezier curves, right? So I thought like a curve could possibly solve this problem I have. Yeah, so I'm just playing around with curves and see if it actually can work to solve this problem. I'm trying to make sure that I can change the shape of the curve, right, to match where the highlighter is. Yeah, but I'm not entirely sure if I'm doing it correctly. How about you? How's your day? Maybe a quadratic curve is not enough. Boring, still locked down. Ah, right. Take care, man. This pandemic is horrible. As I drag the control point around, right, we can kind of get a sense that the way t as in the value determining the interpolation, right, from the start point to the end point, t kind of like increases at a different rate. Yeah, like how do I put it? If you notice at the top, right, the red dots are a lot more packed than the ones in the bottom. This might affect how I want to do things later. Let me think. I guess I will just use quadratic. Yeah, I'll use this quadratic curve first and see how it works. Let's see if it works okay. Well, time to switch out. Time to stop using a sine curve and use a quad curve. Okay, let's try it out. I feel like I'm overthinking this. perhaps I don't even need to spend this kind of effort on a word selection screen. Let's see. What am I looking at? Here, there we go. I'm to change this. Draw debug curve. Or rather draw curve for debugging purpose. To get rid of some of the magic numbers I have here, 0.9, 0.75, horrible. Let me see, how do I redo this part? Oh, one more thing. No, one more thing. I need to test something else. I want to see if... well, I don't even know how to express myself. I want to see if the t value along this line, t as in t goes to 0 for the bottom, t goes to 1 at the top. I want to know if, or vice versa, right? I want to know if the t matches the t along the curve. Let's call it t prime. I don't think so. I think they increases at different rate. But it's good to test it out. Let's test it out. So, what should I call it? Vertical T? So in this case, T... Okay, hang on. Mouse... mouse Y divided by H. This would be the T. Curve T. No, I'm just going to use this T, throw it into the quad curve function. Starting point is top for 0. Bottom is when t is equals to 1. Handler is, well, handler is the handler. Handler is determined by the position of the mouse cursor. Then I have this point here. Let's draw this point. Temp point. Let's draw it in green. And then let me just draw a line in the middle so I know. Line in the middle, draw a line. From where my mouse cursor is, draw a line. Line color. I mean, I guess I can do it like this, but okay, I'll do it like this. Loop from top to bottom. Top bottom. Oh my god, it's so messy. Vertical T. So this is supposed to be a Y. X would be where my mouse cursor is, I think. No, X will not be that. I'll just make it a big number, minus 1000. 1000 to 1000. So messy. Okay, let's see. Okay, oh, and the blue line is not very clear, is it? Hang on. White. Yeah, you can see that the green dot. Okay, you know what? I need to draw the green dot below. Ah, let me do that. So if I want to be able to use the curve properly, I need to make the green dot match where my mouse cursor is, right, in terms of its height. So let's do a little math for that, I guess. Right, see? So yellow dot specifies where I want the green dot to be. I want the green dot to be here, right, at this level. But if I were to use the same T, right, calculated from the yellow dot, I'm not going to get the correct position, right? The green dot is all the way up there, which is wrong. Yeah, see, the increases at different speed. That was my worry. So I need to transform the T from one space to another. Okay. Okay. I knew it. I mean, we can tell, right, just from seeing how the density of the dots is different if you just trace the shape of the curve. Okay, so an additional problem to solve. Let me see if I can solve this. Wait, I think I wrote it on my notebook. Let me take a look. Let me think. Okay. Straight line. So this is the curve. Curve. Let's make it bigger. Curve. Curve. Can't draw. Save my life. Okay, whatever. I have a curve. Now, let's draw the shell. Let's draw the shell. The shell of the curve. Something like this. Then there is a particular line, right? The equation of the line that we want to find, which is this one. So supposedly, if let me think. Let me think. It's t equals to 0, t equals to 1 here. Along this line, I need to find t prime, the corresponding t for the curve. I'm not sure if I know. Not sure if I know the answer to this. If I don't, I'll just I'll just work out the math off stream. Okay, let's see. So I want to find the t, the corresponding t here, which is the problem. What is the corresponding t? A, B, and C. Hang on. Don't really have the confidence to do this on stream. I'll just wing it. I'll wing it. A, B, C. Yeah, actually, how do I find the corresponding? Okay, so maybe let's think about the equation of this line, this purple line. I guess we can do this, right? Y equals to mx plus c. In this case, I know the y, right? The y is determined by this, right? The y is determined by this green dot. So the y is given. Y is given. Only the y is given. I don't know the rest. I know the y. I want to find out the x. But I don't know m and c, right? How do I find m and c? Oh no. I guess I have to work backwards, right? Since I know the equation of the line for A to C and C to B. Oh, do I really have to do that? Damn it. Should have prepared. I've done this in so long. Okay. Y equals to mx plus c. There is a y equals to mx plus c here, here, and here. 3 of them. Let me think. Oh, okay. I mean, I guess I can find. I guess I can find the gradient of, say, this line, right? A to C. A to C. Alright, A to C. Y equals to rise over run, right? Probably doing this wrong. To find where it intersects the y-axis as well. I think I should not be doing this now. I will just stare at this for a bit, and if I cannot do this on stream, right, I will solve this off stream, right? Take a break, solve it off stream. So it will be a short one today. In fact, I still have part-time work that I have to finish up. Goodness, work is never ending. Yeah, so I'll just stare at this for a bit. Right, this is what happens when I don't practice this enough. What if it's a parameterized equation of a line? What if I do this f t equals to a plus t times c minus a, right? This would be one representation of a line. Would that make it easier to solve my problem? Let me just denote it by saying that this is a point, 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 point. If I can find the equation of this line, this purple line, I think I can solve the problem. And I should be able to find it, right? Well, actually, the curve is just a polynomial, right? So I can solve for intersection with this white line, right? Can I? I've not done this in so long. I think I can do it. Yeah, I think I can do it. It'll be another one, right? T equals to C plus T times B minus C. So there will be a certain T, right? And this T matches each other. This T is the same as this T. There will be a certain T that will lie on this very specific line, this purple line here. Whoopsie daisy. It's probably a really simple solution, I just didn't see it. Oh, I should not call this F. It's just going to confuse myself. Quite G, maybe? Oh crap. Thickness of the line. It's not there. There we go. G. There's a point as well. This function returns a point. F G What's next? I should probably do research online. Just a moment. Quad curve. Polynomial. How does a quad curve polynomial look like? If I write it out, can I solve for intersection? I should not be solving this on stream, right? I need more time to think about this. Crap. Well, if I'm not going to be able to solve this, then what should I do now? Make a level. Okay, let me just for the record, right, reiterate what I need to solve so that I can look back at this and try to understand this. So I want to be able to control the shape of the curve for a very specific reason, and that's that. So I have this is my word selection. If you look at the, oops, hang on, I accidentally commented something away. Where's my button? Word button. There you go. So I need this back. It's a very specific problem. Come on, compile please. Okay, I have a very specific problem. Probably not that important, but you can see that I'm not very pleased with the fact that like this button here at the bottom is supposed to be the main focus, right? That's why the stats is being displayed here. But as you can see, this number is a lot more. It's brighter. It's much brighter than this one, and that's because, right, the opacity of my number and as well as this position, right, is based on this curve here. This very gentle curve, right? It's a sine curve, and being a sine curve, the peak of the curve, right, is in the center of the screen, and that's not great. That's not what I want. So what I want, right, is I want the peak of the curve, right, to be somewhere inside this box. And then from there, right, I calculate the opacity of the number, and thereby making it brighter. In a sense, I'm not entirely sure if I'm making sense here, but yeah, I want it such that the shape can be controlled. Shape of the curve can be controlled, so that I can make like minor adjustments to the display of the label. So that's why I have this, right? I want to test this out. So this is a quadratic Bezier curve, and from here, it's obvious that we can control the shape of the curve, but the problem I face now is I need to calculate the intersection between the white line and the curve itself, and that's where the math comes in here, and I'm too rusty to do it on stream, so I might have to do this offline, right, or look up the solution if there is a solution. I mean, there should be a solution, of course, but I need to spend some time to look into this. Right, the problem being that I cannot use the same t, right? I cannot calculate how do I put it? The t value that I calculated from this yellow dot, right, which matches my mouse position, I cannot just use the same t and then throw it inside the curve function, because as you can see, the green dot, in terms of its y position, it does not match. It does not match where the white line is. Right. The intended outcome is that I want the green dot to be where the white line is. Right. Essentially, the intersection between the white line and the curve. So I need to solve this problem. Okay. Let me just restart everything. You know what? Maybe I'll just keep this a short stream today, right? Just 1 hour. I mean, I managed to set up the curve, right? The curve is it's a rather simple function, right? It can be done in a single line. I just need to solve the intersection, right? The problem, the intersection problem. So I need to do that on paper. I don't have the mathematical proficiency to do it on stream. So I'm gonna ponder over this problem offline. Yeah, let me just take one last look at this. Yep, okay. Yeah, I'll think about this off stream. Whew. It's a pretty uneventful stream. That's fine. I needed some time away from my part-time work, so I was just came on stream and do some curves. Now's a good time for me to think about this off stream and then continue my part-time work. So yeah, whoever's here, thank you very much. It's time for me to head off. Right. So goodbye.